Now, where students really kind of struggle with this, you could do this, but when I make my list for nitrogen, what's the problem with it? It's part of everything, right? Nitrogen's everywhere. And so I've got nitrogens here, I've got nitrogens there. So the mass on this side alone would be 1 times 1 plus 1 times 2 times 1. Just for that side. So instead of doing my list by elements, I use my second trick, and that is our polyatomic ions. If I see them on both sides, then we can keep them together. So this list I'm going to keep my polyatomic ions together.
Whenever you write down the ion, you have to put the subscript with it.
This is part of that piece.
Okay.
And that's going to be the key here. How many of these pieces do I actually have? I have one of the piece, but the piece has 4 hydrogens. So notice here, we've got this 2 from the outside of the parentheses. This piece has 3 oxygens.
But it's saying like there's 2.
There's 2 of those. So when we do that, that's this piece is saying PB, and I have an N. Like that. So it's 6 oxygens there. One thing that greatly helps with this is if you identify your polyatomic ions, let's go ahead and add back in the parentheses here. We usually don't show the parentheses if it's a 1, but I'm going to go ahead and show it because it greatly helps to conceptualize it. And this is one of the disservices we do to you by giving you online tests, is we don't bother making you memorize those because people could just have the list out in front of them anyway. All right. But if you've got this in your head that it's one piece, you would see that over here I have 1 of each piece. I'm not going to balance it based off of that 4. We'll balance it based off of this 1. And that's kind of the key here, is those parentheses. When I do this side, I'll have an NH4, NO3 down here. So when I do this NH4, I don't have 4 of them, I have 1. I've got 1 chlorine, 1 lead. How many nitrates do I have? 2. This side I've got 1 NH4, 2 chlorines, 1 lead, 1 nitrate. Now this part becomes a lot easier, but I had to keep these together in one piece. Now, if they're not if it's not on the same thing on both sides, if I don't have an NH4 on both sides, I can't do this. Versus if I was making ammonium like that. All right, how do we want to balance this? In front of my ammonium chloride. So a 2 there changes this to a 2, changes this to a 2. A 1 here. Okay. A 2 here. Okay, so that gives me a 2 there, a 2 here, and a 1. We're done. Now, if I want, let's double check this, and we're gonna see what we're saying. This has two of these. See how that's saying that? Okay. This says I've got one of these. But it's got two of these pieces. This says I got two of these. So I've got an N with 4 H's. An N with 3 oxygens, but there's two of those. And then I have one PB and it has 2 Cl. So for a lot of us, we get kind of lost on what's going on with the coefficients and the subscripts. So this is what this is saying. Now all we could do is come in here and physically count them. I've got 1, 2, 3, 4 nitrogens. For hydrogens, I have 8. I've got 1 PB. I've got 2 CLs. What else we got? We got oxygen. 6 of those. Making a list. All right, how many nitrogens do we have over here? 1, 2, 3, 4. Oxygens, we've got 1, 2, 3, 4, 5, 6. That works out. 1, 2, 3, 4, 5, 6, 7, 8 for the hydrogens, 2 chlorines, 1 lead. What can I say about this equation? It's balanced. It's balanced. We've got the smallest whole number ratio, so we have the same on both sides. All right, let's get a little more practice. But those are our two main tricks that we'll use: lowest common multiple and polyatomic ions. So when I see those parentheses, I key up on those. I've added some things behind them. Those are called the. We have 4 that we commonly use: solid, liquid, gas, and then AQ is aqueous, means it's dissolved in water. This would be, assuming this is acetone, I'm going to be doing a combustion reaction of acetone. First off, you figure out how many coefficients it has. And you'll make a list of how many of each element you have on each side. Then we're going to change those coefficients. Keep in mind, you cannot change the subscripts, only the coefficients. We can't change the identity, only the amount. Think you have it? You're looking at it going, no, I made it too easy. Let's say you had, what do you come up with? Give me the 4 across, the ratio.
1, 4, 3, 3.
Let's see, if I'm using that, then my carbons would be 3. My oxygens would be 9. Hydrogens would be 6. Over here, I'm going to have 3 carbons. Indeed, I will have 9 oxygens and 6 hydrogens. How about that? Four, 3, 3. I'm going to run through how you did those. Let's see, I'm going to write these that we've been writing. Carbon, hydrogen, oxygen. The hard part was this 3. Okay. It's found in both locations. Let's see, then you probably started here and here. Change that to 3, this to a 6. Notice I didn't do that intermediate step after I changed that 3. I'm going to come back and do that all at once. That's where you got the 9. So what algebra did you do to know what to put here?
Well, I figured that I needed 9.
Uh-huh.
So I was like, well, what times 2?
So something
gives
times
me-
2.
Gives me 8. You have the extra 1.
So you saw that you had this number here.
Mhm.
Why didn't you want to change this number? Because we technically, if this is X, I could have treated this like Y because I could change that too.
Well, those are already balanced with the other side.
You've already got the carbons and the hydrogens done. And so what she's saying is she does not want to change that number. Does not want to change that number. You can if you have to, but we prefer to not have to. All right, so then you said, I want to keep that a 1. Then you said this has to come out before 8. All right, exactly right. Now, another thing that's going to help me here is things we don't really usually think about very much, but any number of times an even comes out to be even, right? So if I have an even number times an odd number, I'd have even. But an odd number times an odd number, I'd have an odd. And so whether I need to change this number, in a large part, depends on the count that's over here. Because it was odd, I want an odd number here. So 1 works just fine. Okay. If this had come out to be an even number over here, I would probably want to go ahead and make this a 2. That way I'm guaranteed an even number on that side. If I get that? If I didn't want to do all that thinking, we could have kept this here, and if I'd gotten a fraction, I'd put the fraction here and then do what? Multiply them all by whatever that denominator is. Okay.
Is OH a polyatomic ion?
It is a polyatomic ion, hydroxide. So if you recognize that it's a polyatomic ion, that means you can come over here. Now, one of the giveaways was that we had 3 here. And you could put a 1 in them. Making all this scoreboard confuses them. They would rather do that 1 step at a time in their head. And that's what I do once I get going on these, trying to do them fast. And I start doing more stuff in my head. But I'm really just going to do the same thing. I'm just not going to write everything down. So I need to pick a place to start. What I'm going to start on is, in fact, this OH. When I see I've got a 2 over here and a 1 over there, how am I going to fix that? Put a 2 over here. That fixes the OH. It might have messed up my K. I'm going to come back and double check. I've got 2 Ks. I'm going to come over to this side. I've got 1 K. I'm going to go ahead and fix it by putting a 2 there. Now I have 2 Ks. I also have 2 CLs. I'll come over here and make sure I have 2 CLs. I do. I got one barium, one barium. This should be done. This is the problem, is I went through a bunch of stuff mentally. And so a lot of the books, and I've even seen some instructors that have told students, you just change the coefficient so you get the same on both sides. Overall, yeah, that's what you do. But that's not enough guidance for you to sit there and go, I don't know where to even start. Okay? So if you don't see one of these shortcuts, if you had not seen this was an OH, you make your list K and O and an H, and you get the same answer. It just might take you a little bit more work. So our long technique always works. For some reason, that long technique gives us a little bit of trouble when I make water. So always allow yourself the chance to look at it and see if the answer jumps out at you. Let's say only about 15 seconds. If it doesn't jump out at you, one of our tricks or the answer immediately jumping out at you, go ahead and start making your list. What I key up on this one is oxygen. I have 2 over there. I only have 1 over here. I'm gonna go ahead and fix that first. Put a 2 here. That messes up my hydrogen. So now I see the 2 over there. All right, we got time for one more. Let's take a nice easy one here. Oh man. Oh, that's a bad one. Add the fact easy gases, nitrogen gas plus hydrogen gas to form ammonia. No, ammonia. This is definitely something you're going to want to practice. It's a skill. You want a 2 right here? Okay. A 3 over here. Winging it. Okay, so you just said you wanted to fix the nitrogens first? Okay, good. And then you said, okay, I'm going to come back and fix the hydrogen. That'll work. Was there a trick that we could have used on this one? May see a trick? No polyatomic. I do lowest common multiple, packs of 3, packs of 2.